Okay, so moving forward in our pursuit of solving quadratic equations and dealing with quadratic functions, let's go into section 6 now, and we'll talk about a fourth way, really, to solve a quadratic equation. Okay, so far this chapter we've looked at solving them by graphing. Again, we were looking for the x-intercepts of a quadratic where it crossed the x-axis. We realized and found that way that we could have one, two, or no real solutions. Then we went on to factoring, and we broke down our problems into separate factors, and then used the zero product property to set them equal to 0, and figured out what our zeros were from those factors. Last time we talked about completing the square, which is really just another way of factoring, but also allowed us to use square roots to solve quadratic equations that we couldn't factor. So we kind of forced the issue into factoring, but then we used square roots to solve. And in that discussion, we brought forth imaginary numbers. We talked about taking the square root of a negative now brings in this new set of numbers called imaginary numbers that deal with the square roots of negatives and how we can use those. And finally, we're going to talk about the quadratic formula and part of the quadratic formula that's called the discriminant. So as you see on your screen there, we have the general form of a quadratic function right here, ax squared plus bx plus c. Now, the nice thing about the quadratic formula is that there's no requirements here. When you factored, we had to make sure that your leading coefficient was positive. You had to take out any commonalities, any common factors before you move forward. With quadratic formula, none of it matters. The only thing that matters is that you're equal to 0. That's it. That's nice. We can have fractions if we want them. We can have negatives and positive. Signs and all that stuff don't matter. You can use it as it is. Just make it equal to 0 and go. So this is what it looks like, and yes, you're going to have to just know this. You can make up a song. People have done row, row, row your boat to this, but that's where we have to go here. So it's the opposite of b, still b, plus or minus the square root of b squared minus 4ac all over 2a. And if we notice what shows up in here, okay, a couple things that show up from our quadratic. We have this opposite of b over 2a. If we remember way back to our graphing section, the first section of this chapter, that is the equation for the axis of symmetry. So that kind of gives us some information. If we look at opposite of b over 2a, that's the middle of our graph, and then plus or minus kind of gives us the other way that we're going with our equation here. So that's important information that's worked into here. The other part is the stuff underneath the radical, the radicand of the quadratic. That is called the discriminant, and it gives us several pieces of information. Okay. The biggest is it tells us how many solutions we have. So if, again, looking without the radical, if I just took b squared minus 4ac, if the discriminant is positive, okay, there will be 2 real solutions. Okay, meaning this will have 2 x-intercepts. If the discriminant is 0, there will be 1 real solution. Okay. If the discriminant is negative, there will be 2 imaginary or non-real solutions. Okay. So I will come back into the problem here. And really, folks, it is a matter of organization, using parentheses, and then really just plugging values in and make sure you pay attention to your order of operations. It's not a difficult thing to use. It looks way crazier than it really is, but it allows us to solve a problem no matter what we have. Okay. So let's start here. 10x squared minus 3 equals 13x. We said the first thing we had to do was make it equal to 0. So let's subtract 13x from both sides and get it in the right form. Okay, so we're left with 10x squared, and then I have a minus 13x, a minus 3, and we're equal to 0. Okay, that's the first and foremost part, get it equal to 0. Now let's identify what A, B, and C are. A is 10, B is negative 13, and c is negative 3. Again, notice that I don't take the variables with for a, b, and c, okay, especially for a and b. They're just the coefficients, they're the number parts. And then we're just going to plug stuff in. Again, use parentheses, folks. It's going to make your life so much easier. You'll be able to organize it and watch out for any little tricks that come up to play. So the opposite of b, which is negative 13, plus or minus. Don't forget the plus or minus. The square root of b squared, so negative 13 squared, minus 4 times a, which is 10, times c, which is negative 3, all over 2a. Okay. So we need to make sure that we are using the right numbers in the right spots. We need to make sure that we are using parentheses and make sure that we're putting things where they need to go. So let's start breaking down piece by piece. The opposite of negative 13 is positive 13, plus or minus, and then the square root. Let's find out what our discriminant is. Okay, so I'm just going to go to my calculator and do negative 13 squared minus 4 times 10 times negative 3, and that gives us a grand total of 289. That's all over 20. Okay, so I've just gone through and done my basic math first here, and then we will go from there and work forward. Okay, well, if I go and take care of this 289, let's check to see if it's a perfect square first, which it is. That's beautiful because that makes life nicer for us. So I have 13 plus or minus 17, because that's what 289 becomes. So this guy right here became 17, and that's all over 20. Okay. Now, if I look, I have two answers. I have 13 plus 17 and 13 minus 17. So we're going to break it up into two different fractions. I'm going to do one as the 13 plus 17 over 20, or 13 minus 17 over 20. And we're just going to simplify that down. So we get to this point, we can break it up into two separate equations. So this becomes 30 over 20, which reduces down to 3 over 2. So there's one answer right there. Or this is negative 4 over 20, which will reduce down to negative 1 over 5. Okay. So again, it's just a matter of really plugging numbers in to your, or substituting numbers in for your variables in the right spots, and then simplifying. So just be careful and take your time. It's not an overly difficult process. It's more just tedious trying to get through and making sure we have it. But it's a great process to use because it allows us to solve any quadratic, no matter what the setup is, as long as we're equal to 0. Okay, so that's example 1. Let's go to example 2 here. Let's try another one. All right, so now again, I have to get it equal to 0 first. In this case, I have two terms I need to move, so I have to add 6x to both sides and subtract 8 to get us equal to 0 here. So that will leave me with x squared. I'll have a plus 6x and a minus 5 equals 0. Now, why this one's nice, if I went back up here, okay, and I kind of looked at this, and I said, well, 10 times 3, that's 30. There are factors of 30 that have a difference of 13. So this one is factorable. I could factor this, and I would end up with the same answer, and probably is quicker than this. But we look at a problem now where I have this. If I multiply 5 and x together, there are no factors of 5 that have a difference of 1. There's factors of 5 that have a sum of 1, but no factors of 5 that have a difference of 1. So, or difference of 6, excuse me. So I can't factor this. I could go and complete the square, but that's a little tedious. I can just go ahead and use the quadratic equation here. So start with it. A is 1, B is 6, and C is negative 5. Now watch your signs. Keep those set up nicely so you don't miss them. So let's go plug it in. The opposite of B, plus or minus the square root of B squared minus 4 times A times C, all over 2 times A. Just a matter of plugging values in and going forth from there. Okay, well this gives me negative 6 plus or minus the square root of, let's see, 6 squared minus 4 times 1 times negative 5. We get a grand total of 56 all over 2. Okay, well 56 is not a perfect square, so we have to go ahead and break it down into its primes. So just like we did a couple of days ago, let's break 56 down into its products. So that's 2 and 28, which is 2 and 14, which is 2 and 7. So if I look for sets, there's a set of 2 right there. So I can bring a 2 out. So now I have negative 6 plus or minus 2. And what do I have left over? Well, it's 7 and 2, so that becomes 14 underneath all over 2. Okay. Now, the issue we run into here, unlike this one, this is going to give me non-whole number answers. So I'm just going to simplify the stuff on the outside. If I notice negative 6 and 2, they are both divisible by 2. So I'm going to simplify those fractions right off the bat. So I'm going to do negative 6 divided by 2, which is negative 3. I have plus or minus. 2 divided by 2 is 1, so that just gets left as the square root of 14. So that's as far as I can go. I can't simplify anymore. I can't break it down any farther without rounding and give me estimates for my answers. This is my final answer here. You could plug them into the calculators and get decimal equivalents, but I like exact answers, so this is what we have for our answer. Okay, simplify the radical if you have to. Okay. The final example we have here, coming way down here, and this will wrap up our quadratic talk as far as solving them goes. Same process. I'm going to subtract 6x from both sides to get my quadratic equal to 0. So I have x squared minus 6x plus 13 equals 0. Take a, b, and c again. A is 1, b is negative 6, c is 13. It's just coincidence that 6 shows up for b again. Plug it into your quadratic. X equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Just repeat it over and over and over and over and over and over again, and it'll stick. Okay, clean it up. We'll have positive 6 now, plus or minus the square root of, let's figure this out. We actually get a negative 16 here, all over 2. Okay, red light. Okay, warning, warning, warning. I have the square root of a negative. So the instant you see a square root of a negative, we should think to ourselves, I is going to be part of my solution. Okay, so I'm going to simplify this stuff. Well, I know that the square root of a negative is I. So that takes care of that guy. But 16 is a perfect square. That's really nice. So the square root of 16 is 4. So the square root of negative 16 becomes 4i. That's all over 2. Now I can't add 6 and 4i and get 10i, so those have to remain separate. But as we saw before, both 6 and 4 are divisible by 2. So I can divide those and simplify this. So 6 divided by 2 is 3, plus or minus 4 divided by 2 is 2, and then we have I in the end. So there's our 2 imaginary solutions. Okay, and kind of how that would look if we were on a graph, as you'd see a graph that would have something where you'd have a graph above the x-axis. Okay, it doesn't ever cross the x-axis, so those would be our 2 imaginary solutions that we have. So that's the quadratic equation. The discriminant, again, can tell us a lot of information. If you know the value, if I notice here, I have a negative discriminant, so I have 2 imaginary or non-real solutions. Okay, up here I had a positive discriminant, so I have 2 solutions. Same thing up here. Positive discriminant, it was 17, or it was, I'm sorry, 289. That gave me 2 solutions. So just looking at the discriminant can tell you really quick what type of solutions you're going to have and how many there are. And it just allows us to kind of move quickly through the solution process. So it's another tool to put in your tool belt as far as solving quadratics. We've looked at graphing, we've looked at factoring, we've looked at completing the square, and now we've looked at the quadratic formula. And that kind of takes us through what we are going to do as far as solving quadratics. So there it is. Hopefully that clarifies anything we need to clarify. So we'll see you in class.